Hey guys, it's Sig from PicoPlanet, back with another video on Processor Simulator. And today you'll see, at least compared to the last video, that we have a lot more processor components available to us. In fact, I believe that we have pretty much everything that we need at this point. So today we're going to be giving it a try, setting up the computer to run the little fill-in-the-display program, and then maybe also putting in like the marquee program and seeing how well that works on our visualizer right here, and that's one of the new components. So we'll end up going over all of that during this video. But the first thing that maybe I do want to comment on is you'll see I have hands and arms and everything now, which is a little bit different from the last video where I just had like the little outline of the ghost hands. And this is just because I've now integrated the meta avatar system. And so therefore you're able to see your own avatar and all the customizations you've applied to it in the game. And I was actually going to film this from a third-person view using the streamer camera that I have right out here. But it didn't end up coming out very well, and I'm definitely going to need to look into the quality of the lip sync for that to be worthwhile. So in the meantime, we have one more first-person view tutorial at this point. But anyway, in the last video, you saw basically all that we had was, if we move these off to the side, all we had was a clock, a processor, these two buttons, and we did have like a couple of wires hanging out here. So yeah, let's put those out as well. And you might remember from the last video we talked about the clock having like this little square wave icon on it and the processor and all of that. But we do now have some little icons that kind of show us what to connect to each device. And so you can see right here, this clock needs a connection to the processor, and the processor needs a connection to the clock, obviously. So that's going to be the first thing that we hook up. And I will just attach those right in. Something you might notice while I'm putting these in is my hands kind of go a little bit funny, and so does the IK, the inverse kinematics on my arm, whenever I stick one of these into the port. And that's just because of a bug that I haven't yet worked out in the force unselectable grabbable. And that's basically something where when I have something that I want to make myself drop, like when I want the player to drop it, it should automatically just like release whatever object it is. However, right now the force unselectable grabbable doesn't seem to be working quite right, and it keeps your hand like grabbed to it even after like it's been force released. So that's definitely something that I need to look into in order to make it not look quite so janky while we're doing this. But in the meantime, we do now have the clock attached to our processor, and now we can go ahead and hook up that reset signal. There we go. I want to put that in a place that makes sense. One other thing is you'll notice right now the hand poses are not very close compared to the old ghost hands. Something to do with how we're like translating the hand poses between the avatar and the interaction SDK is what controls like these hand poses. So that's something that we will get figured out in the future here. And although I don't think that this program is going to use it, we might as well also hook up the interrupt request line to the processor, because why not? And now with all of this hooked up, I guess it would make sense to start looking at some of the new stuff that we are adding here. So I'm just going to move some of these buttons out of the way and maybe make it look like the wires aren't quite as unrealistic as they seem. Even though they are just Bezier curves that handle how these look, basically. The wire draws a Bezier curve between these 2 points. It's a cubic Bezier curve, and then it just happens to have right out here, it might be quadratic actually. I'm pretty sure it's cubic. I think it's a cubic Bezier curve. And then right out here somewhere are 2 control points, and those are basically just what give it the curve. And so based on the length of the wire, the control points kind of get farther away. So if I pointed these two in the same direction and pulled it apart, you can kind of see how it extends the wire out in that direction. And that's just because it's creating a control point out here that's kind of pulling the wire out that way. But this is a nice, easy, low-cost solution to making these work. They're currently going in the update every frame, and it just checks to see if they've moved since the last frame and skips the calculations otherwise. But now let's get started looking at some of our new stuff here. We have this memory bus right here. And I've been trying to pick some icons out of the Bootstrap icons package to find some that kind of represent this well. So I kind of felt like this like little grid of 6 different like 6 different squares would represent the memory bus kind of well, because definitely seems like 6 devices attached. That's probably a decent upper limit for this. I could always make a memory bus that's like taller and give it more and more ports. But we're going to connect it to the computer using a single cable, and you might find that a little bit interesting if you know anything about the 6502, because it uses both a address bus and a data bus. The address bus is 16-bit, the data bus is 8-bit, and those two things are kind of what actually connect to every component. So this is not entirely the most faithful recreation of how this works, especially considering that we just have like one big wire right here. But the point of this is to basically separate out that 16-bit address bus and 8-bit data bus into a ton of different ports that each of our devices can connect to. So since we're focusing more on the logic and the programming in this game, we're just going to use kind of like this block diagram or flowchart sort of method to connect everything. And I think that that looks pretty good in general in terms of connecting stuff up. So next thing we need to connect is another new component that we have here. Technically not new, definitely one of those that was in like the big gray cube computer from before. But this is the EEPROM. And you'll notice it has 2 different ports on it actually. I tend to like to have the right port be stuff coming out and the left ports be like inputs. So this right port is what actually gets connected to our memory bus, and you can kind of see that in the visualization here. So let me connect that up and then also get that one in there. And you can see it just says connected right now. I'm hoping in the future to write a bit of code that shows what addresses it's actually associated with. But anyway, to go back to this, the other side of our EEPROM is actually going to be where we can attach this EEPROM programmer. And in real life, you would have to take like an EEPROM chip like this big and stick it into a programmer that maybe you could attach to your computer by USB or something like that. And that is what would actually write all the data to the EEPROM. So we're going to recreate that with this little EEPROM programmer. And this thing then connects to both our assembly editor right here, but also to our machine code editor there, and tells them what EEPROM to write stuff to. So in the future, once you're able to spawn components, you might even be able to swap out EEPROMs. You could have 2 of them sitting on the desk, program each one, and then just swap them out, depending on which program you wanted to run. So we don't need to connect this quite yet. We might do that a little bit later in the video when we are actually writing a program here. But we definitely do need to connect the RAM, because that is used in our display program. It's used specifically for the 0 page to store some of those positions for where we're writing stuff. And we can plug these into really any port we want. It doesn't actually matter, but I was just kind of filling it vertically here. Anyway, the last thing that we need to connect to our memory bus here is obviously the display. And you can see I kind of made a little port extender here because reaching this far back on my desk gets pretty sketchy with my monitors and all of that there. So I just kind of brought this out, and it makes it a little bit easier to plug stuff in. So let's grab a new wire here. We could maybe stick that right in there, and you see it still says disconnected until it's actually connected to the other device. And put that there, and unfortunately these 2 wires are kind of crossing paths, but that's okay. So I'm hoping now when we start our clock and run the computer that this all works here. So then we can do that just by clicking the clock to on like that, and then we can bump up the speed a little bit here. And you can see we're already starting to get some of our program running. It's writing out to the first line. And we can set it to turbo mode, and off it goes. So we now do have like this computer fully connected here, which is pretty impressive in my opinion. This is a great way to show people how the computer can be put together and what all of the main pieces of it are. And just to demo some stuff here, if I press the reset button, resets to the beginning of the program each time. The memory bus is telling any device attached to it to reset as well. And that does include stuff like the RAM, for example, at this point, and also obviously the monitor. when we connect to the versatile interface adapter in a little bit, that will also be something that can be reset so that our ports get reset whenever we hit that reset button. So at this point, let's turn off our clock and honestly bring down the speed a little bit. I'm thinking that we can rewrite that little marquee program that runs in port B here. So maybe we should get started on that. It should be pretty quick. So the first thing, we all know what we need to do. We need to load a couple of values into our A register, and that's going to involve using the immediate addressing mode, which I just picked out the wrong one here. I definitely need to trim down the stack because some of these aren't even used. Anyway, let's attach both of those, and we remember what our couple of hex codes were for these. That was going to be 55. 55 for, let's see here, this one, starting with 0. And obviously, since it's assembly, we can put it in like this and it looks nice. And if we change it over to hex, we can do AA in hex here. There we go. Still kind of working out some issues with the positioning, obviously. It seems like the farther we get away from the origin, the less accurate the positions get with this hand. Not entirely sure what's up with that. Maybe it's potentially an issue with the IK limiting how far we're able to reach. But anyway, if we put in AA, we can see that that one is then the other version, starting with 1. And those are going to be the two things that we need to load into the A register. And then we're also going to need to be able to store these out. And I grabbed the wrong one here. Did it again. This is a pretty compact thing. I feel like in the future I should probably separate each one out a little bit, separate them out vertically some, make that all a little bit easier, because I'm hoping that at some point I can have just a simple switch between the assembly options, like all the assembly commands, and then these opcodes right here. Imagine something like that, maybe, where you can just slide it up and down and switch between assembly and machine code. Anyway, we're going to be storing these all out to port B, which we know is on address 6000, I believe. So let's stick those together right there. 6000. Great. We're also going to need an org directive, and my desktop is right there, so I do need to recenter before I actually can grab that. So give me a second. Great. Now we can grab our little .org directive right there, I'm hoping. Yes, wonderful. And our org directive is going to start us out at 8000 because that's where the EEPROM starts. Now, with that taken care of, we can also grab a label, I think. We're going to want, oh yeah, just one of them. And we can label, accidentally just grabbed that, we can label this loop, because we want our marquee to loop for a while, so we're just going to make a couple of these loops. And one of them we're going to want to stick to jump, so that we automatically just jump back to the beginning of our program. And I'm pretty sure that that's all we need. So let's start off with our org directive, our label loop, load A. Oh yeah, those get really far away, huh? Then store A, load A again, store A, and finally we can jump to our loop. And if we click assemble, it should put together that program for us into some machine code. And if I kind of look out of my headset, I can see that it has written some assembly or some machine code there based on this assembly, I should say. And in order to upload it with that upload button, we're definitely going to need to connect our programmer here. So let's find our EEPROM right here, and we technically don't need to disconnect it, but I'm going to right now. Which you just noticed the screen went black. The memory bus automatically sends a reset signal through to the processor whenever anything is connected or disconnected. So let's now connect our EEPROM programmer up to the EEPROM itself and hit upload. And there's upload. I'm kind of hoping that this works here. I'm not entirely sure if it's going to or not. But hey, we're about to find out, huh? So yeah, let's finish disconnecting this and put it right back on our memory bus. And then I guess we kind of do need to attach our versatile interface adapter here. So there we go, now it shows that it's connected, and let's grab another wire. I can just keep that attached to our programmer for now and set it off to the side. And connect this one to our versatile interface adapter visualizer. And let's just hit manual tick a couple times to see exactly what happens here. So our first command's going to be A9, I guess, which does make sense because we're loading A. And then 55 is our operand. Then 8D is for store A. 00 and then 60 should come afterward. And it does, look at that. Our versatile interface adapter visualizer right here lights up with that marquee effect. Let's go for a couple more ticks. So we're going to load in AA this time into our A register. And then 8D to store it. 00, 60, and it switches the lights. So we could now maybe turn on our processor, and you can see it kind of going through each of those commands and switching it back and forth. We could obviously bump up the speed a little bit if we wanted, maybe to like 10 times a second, maybe 10 hertz. That gives us a pretty decent rate of switching back and forth there. And that is pretty much all I have for this video. We can see that our computer got kind of complicated right here. But this is a pretty good demonstration of how the workflow might go. You know, you might start off in a tutorial putting together the computer with some sort of memory device attached to it. Maybe it's the versatile interface adapter, maybe not. Maybe it's like more like that monitor or something else entirely. And then you can attach whatever you need to there, write your program in assembly or in machine code by hand back there, and then attach your programmer, upload it to the EEPROM, put it back on. And that's very similar to how writing a program for the 6502 in real life is going to go. So that's all I have for you today. Thank you so much for watching, and I will see you again soon in the next one.